For this lesson, we're going to look at something called present value. It is very similar to compound interest. In fact, it's the exact same formula except rearranged. So let's just take a look at what present value is. It's the amount of money that you have to invest today at a given rate, compounding frequency, and term in order to get a final amount. So in other words, if we take a look at the compound interest formula, which is this one right here, normally we know what the principal is, we know what the interest rate per compounding period is, and we know what the total number of compounding periods are. And then we just plug them in. So we know P, we know I, we know N. We plug them into the equation, we find out what A is. What this lesson is about is basically saying, what if we know what final amount we want to have, and we still know I, and we still know N, can we rearrange it to find out what P is? Can I find out how much money do I need to invest now so that I'll have this amount of money later under certain conditions? So really, it's just using the same formula and solving for a different variable. And we could just use this formula exactly the way it is, pardon me, but what we like to do in math is often to make things a bit easier for ourselves. We often rearrange the formula to get what we want isolated. So it'll save us a little bit of work if we rearrange the formula. So what I'm going to do is I will take this formula here and I'm going to write it again, except I'm going to flip sides so that it's the exact same formula for starters, except that I've got the A on the right and everything else on the left. So all I did was flip the sides around. And then I want to isolate the P. So in order to do that, I will divide each side by 1 plus I to the n. In other words, I'm going to divide this side by 1 plus I to the n because I want to get rid of it, right? If I divide by this chunk, then that makes it go away. It just leaves P by itself. But it means I have to divide the other side by 1 plus I to the n as well. And that's fine. And I can just rewrite that like this. P, I got P by itself now, is equal to A. I could rewrite this as 1 over 1 plus I to the exponent n. I'm just going to change one thing. I'm going to put the bracket in a slightly different place. Put the bracket here, like this. And remember, though, that this, we've seen this before. We've seen fractions with exponents in them. And if you think back, maybe I'll even go back to a previous exponential thing. If we go back to, I guess I don't have it here, I've erased it. But remember these kinds of things with the negative exponents? Like 695 to the exponent negative 1 was the same as 1 over 695 to the positive 1. If we were to go backwards from this to this, basically it means I could take something like this and rewrite it, not as a fraction, but just with a negative exponent. So all I'm trying to say with all this talking is that what we can do is we can rewrite 1 over 1 plus I to the exponent n as 1 plus I to the exponent negative n, just using that idea of negative exponents that we just talked about. So now we've got this formula where P is by itself. Remember, P is the principal. So this formula, I can find out how much money I need to invest to get a final amount A under certain conditions. And now that we've rearranged it like this, it's almost just exactly the same as the compound interest formula from the previous lessons. And so if we just get the values that we need, as in I and N and A, we can type it in, and it'll take no more time than compound interest formula. So evaluate, round to 2 decimal places. So 2,000 times 1.05 to the negative 8. All this example is it's taking a question and already having it set up for you. So in other words, it's as if I've given you all the information. I've already figured out what A is. I've figured out what I is. I would be the 0.05. I figured out what N is. It's the 8. And I've stuck it into this formula here. That's all it is. This example has just got it so that it's already sort of pre-done for us. But once we've got all the values filled in, then we can just type them in our calculator. I'm going to use just this one here. And so if I go 2,000 times 1.05 to the exponent, which is that x to the y button on my left side of my screen, and I say, got to remember the order to do it in for this one. I think negative 8. Yeah, it's showing. If you look in the top right in the baby blue color, you can see what I've typed in. So 2,000 times 1.05 to the exponent negative 8. I get 1,343.6787, etc. So that's telling me that I need $1,353.68, and under those certain conditions, that will grow to become $2,000 at a later time. So what you need to realize for today's lesson, present value, finding P is always going to be less than A. Let me just fill in the numbers first. And this is dollars. So remember, let's go back up here for a second. Here's P, here's A. A is the final amount after compound interest has been added. P is what we start with. P is always going to be less than A. So this answer here needs to be less than the 2,000 that we started with. That should always be the case. And what's always going to make that happen is this negative sign. That negative exponent is what's going to make us have a smaller number for P than for A. Let's get rid of some of this stuff so it's not cluttered up. All right, so here's 5,000 times 1.02 to the negative 15. So what I'm expecting when I do this is I'm going to have an answer that's less than 5,000, right? 5,000 times 1.02 exponent negative 15, 3,715.07 cents. So as you can see, that's really quick to type in once I've explained how everything works. It's not a time-consuming thing to do. You just need to understand the concept. So let's do a couple where we actually set them up ourselves. Determine the present value of each amount. So present value. So look for that term. When it tells you it's present value, that's your giveaway that we're going to use this formula, right? The one with the negative exponent. And $1,000 is our final amount. We need that 4 years from now. We calculate the same way as we did for compound interest. So it's going to be that 0.08, that 8% as a decimal, but then divided by the number of compounding periods per year. So again, you got to look out for that key word. In this case, it's semi-annually, telling us that it's twice a year, 2 times a year. So we're going to divide by 2. And so I is 0.04. In other words, if you are getting 8% per year, but you're doing it twice a year, that means that you get 4% each time. 4% once, and then 4% again 6 months later. Number of compounding periods total is the 4 years times twice a year. If you do it twice a year for 4 years, then you're going to do 8 altogether. So then we've got A, I, and N, and we can just set up our own equation like you saw in example 1. Remember, it's always 1 plus I, so it's going to be 1 plus 0.04. So the 0.04 that we saw here is still here, but it's got a 1 in front of it. That has to be the case. And 8 is our N, but for present value, we have to have that negative sign in front of it. We have to have that there to make things work out. Let's use a different color. All right, so if you leave out that negative sign, you're not going to get the right answer. So we type that in, and you've seen me type in a couple now, so I won't take up your time doing that now, but it works out to be $730.69. $5,000 is needed in 10 years, invested at 6% per year, compounded monthly. All right. So I is 0.06, compounded monthly. How many times a year? How many months are there in a year? That's 12 times a year, right? So we divide by 12. That works out to be 0.005. And it's for 10 years times 12 times a year, so we're going to do it a total of 120 times. So P is going to equal 5,000 times 1.005 to the exponent negative 120. And again, we're looking for a number that's less than 5,000. And what we'll get is $2,748.16. And in the next one, James wants to buy a used truck for $12,000 in 3 years, so in the future, right? So it doesn't say anywhere, oh, use the present value formula for this one, but anytime a question tells us that we want a certain amount of money, in other words, he's going to need to have $12,000 3 years from now, so we have to use the present value formula. He will save his money in an account that pays 5%/A. This means, literally, this means per annum. That's Latin. It just means per year. Annum is Latin for year. So in other words, it's 5% a year. So sometimes you'll see questions that have that /A in there. It's just the same thing, 5% per year. Here's the key word though, quarterly. You've got to know that that's 4 times a year. How much money does he need to put into the account now? So in other words, find the present value. A equals 12,000. I equals 0.05 divided by 4, which works out to 0.0125. N is the 3 years times 4 times a year, so it's 12. Present value equals 12,000 times 1.0125 to the exponent negative 12. So again, he needs 12,000 3 years from now, but luckily because he's going to earn compound interest, he won't actually need to save that much or put that much aside right now. It'll be less. And what it works out to be, again, I won't type it in right now just to save some time, but what it works out to be is $10,338.10. So this is our answer for what he needs right now. If he puts $10,338.10 in an account right now, under those conditions, he will have $12,000 3 years from now. Last example. Caitlin needs to pay off a $40,000 debt in 5 years. Future. PV is short for present value. So in other words, we're using a present value formula again. Banks willing to accept payment today at discounted at an interest rate of 3.5% compounded monthly, 12 times a year, right? How much is the bank willing to accept today? So sometimes this is just a twist on the setup, but it's the exact same kind of question. So someone borrows money and they're expected to pay it back at a certain time, and they're supposed to pay back a certain amount because the bank is going to charge interest. If, say, Caitlin had a rich aunt who passed away and left her a bunch of money, and she didn't feel like having that debt anymore, she wanted to pay off the loan now, in theory, she should be able to pay off less than $40,000. Yes, she's willing to give the bank $40,000 5 years from now because, then she's hopefully going to have it. But if she suddenly finds that she's got money today and she pays them back early, it would make sense that she shouldn't have to pay $40,000 because part of that $40,000 would be the interest that the bank is collecting over those 5 years. So how much should it be? Well, it should be less than $40,000, but we can work out exactly how much it is using the present value formula. Now, the interest rates don't always work out to be nice, even numbers like the ones we've done up till now. If I do 0.035 divided by 12, I get a longer decimal. Let's actually type that in, see what we get. So as you can see, it works out to be a longer decimal. In fact, the calculator is just rounded the last digit, shows to a 7, but I think it's just going to keep repeating as a 6. So they don't always work out nicely. So it's okay to round it, but you have to, for interest rates, a small change in interest rate makes a big difference. So you need to keep quite a few decimal places. I think you should keep at least 4 decimal places, maybe 5 or 6. I'm going to round this to 0.00292. So I got 5 places after the decimal going here for a fair amount of accuracy, and you need to do that. Can't just round it to 1 or 2 decimal places. Even 3 is not enough. All right, and it was 5 years, and it was 12 times a year, so that's just 60. But again, once we've got these values, once we've interpreted the question, which is the main thing, and then got these values, doing the math does not take any great effort. Just remember there's a 1 inside the brackets, 1 point whatever I is, so 1.00292, and there's a negative sign on that exponent. If you ever do it, if you ever forget the negative sign, what's going to happen is you're going to get a number that's bigger than what you started with. So if I forgot the negative sign here, I would get P as a number that's bigger than 40,000. That should be a tip-off to me that something's gone wrong, because present value should always be less than what you started with, what you're going for. But putting the negative sign in there, what I get is $33,580.14. So Caitlin should be allowed to pay the bank back $33,580.14 today, and that would be basically equivalent to the $40,000 that she owes them 5 years from now. She's just paying it off early and saving herself the interest.